Hello, class. My name is Anthony, and this is my partner.
Hello, my name is Adrian.
And today we're going to be giving you a quick walkthrough of our mushroom classification project for our artificial intelligence class. The dataset that we are using for this project is a mushroom database that we acquired from Kaggle. It initially had 3,401 images, but we reduced this dataset to the 1,890 because one of the classifications had like 4 times the images that the other classification had, and it was giving our model some classification bias. For our data set, we used a 20% validation split, where 80% of it was for training and other 20% was for validation. And the dataset itself was comprised of 2 classifications, the edible squirrel cats and poisonous squirrel cats. Our test set was comprised of 10 total mushrooms, which we acquired from Google Images, 5 of which are edible and 5 of which are poisonous.
So for our initial classification, um, this is after comparing it or testing it against the model. We had 6 correct, and after that we augmented the data where we used random flip, random rotation, random contrast, random crop, and random zoom. And as you guys can see here, uh, all these images to the right, on the right side of the screen, are all images of mushrooms that were augmented through uh, some of our code. Now, for the data augmentation classification, if you guys look through it, um, there are 7 out of 10 correct. Now, if you were to compare this to the original model, which both were ran for about 50 epochs each, for which ran for a minute, around a minute. The original model had 89% accuracy in training, and as I mentioned before, had a 6 out of 10 correct classification against the test set, compared to our data augmentation model, which had a 79% accuracy in training and had a 7 out of 10 correct classification against the test set. This is interesting as the accuracy drops, but when you classify it against the test set, it gives us a better percentage. And just so um, you guys can look more into it, Anthony will have a chance to give you all a demonstration as to how our code ran.
Okay, so first things first, we got our data set from this website here, Kaggle, which shows that it had 3,400 files, and the four, the dataset came with 4 classifications, but we condensed them into 2 different classifications just for simplicity's sake. And so in this section of code here, this is where we split the data set into 2 different sets, the training set and the validation set. And it shows here that there's only 2 classifications, which can also be seen here on the on the left-hand panel, the 2 different classifications for the test set and the mushroom data. This section of code here is how we normalize our data set. so that every picture is the same dimensions and has the same color scheme. And this section of code is just for displaying the images. Here is our actual model that we use for for classifying the images. Here is our loss function that we use. Our optimizer, we use Atom. And then here is the training for the model itself. You can see it shows an accuracy of 89%. But this was only for one iteration. Also, on this line of code here, we loaded a model that we had already trained. So this one iteration had very little impact on the accuracy. In this section of code, we're importing the test set, and then here we're displaying the test set, which we can see running here. Now here we're reloading the model in case it changed, and then we're attaching the soft maps to the model on this part. It's actually not easy. But now we are. So here is the model running non-augmented to make its predictions on the test set. So as you can see here, it classified this one correctly, classified the first one correctly, the second one, the third one was incorrectly classified, the fourth one is correctly classified, fifth is incorrectly classified, sixth is correct, seventh is incorrect, eighth is correct, ninth is correct, and the 10th is incorrect. So overall we have 1, 2, 3, 4, 5, 6 correct classifications out of 10. This next section of code here is the data augmentation, and these are the layers that we'd use. This layer here is just for normalizing data if it's not already normalized. And then here we created 4 different augmentation data sets so that we can train our model on not just one variation of the random flip, random rotation, all the random whatever. So we wanted to have multiple variations of it, so that it's not just training on one set. And this image here is just showing what the mushrooms look like after having been augmented, after the data set has been augmented. And then here is where we fit the model to the augmented data sets against the normalized validation sets. But we also fit it against the normalized data set again because we didn't want it to just be fitting against the augmented data. We still wanted it to fit itself against the normalized data set as well, so that we don't lose any accuracy against the regular data. And here we're loading the augmented data, the augmented model back into the program. And this section here is where we're making the predictions for the augmented data set, or for the augmented model, rather. And here I will show it running. Alright, and this is the output. So we have the first one being classified correctly, the second one is correct, the third one is incorrect, the fourth one is also incorrect, the fifth one is correct, the sixth one is correct, the seventh is correct, the eighth is incorrect, the ninth is correct, and the 10th is correct. So in total we have 1, 2, 3, 4, 5, 6, 7 correctly classified mushrooms. And that's pretty much all for our code. So back to the presentation. So in conclusion, the data augmentation did end up helping our image classifier, even though it produced a slightly lower accuracy during training. It still managed to classify the images better than it had done before.
And of course, this is due to, or most likely it is due to it having more um, data to go off of.
Yeah, and yeah, that's all we have.
Concludes the presentation.
Thank you for watching.